Okay, so we're back doing the Francis Barnett again with the charging system. Hopefully we'll have a little bit more success this time. Yeah, it didn't go so well as you saw the last one. But anyway, right, we've got another little plastic disc. Got some much thinner wire. This is 0.355 millimeters thick. Should be able to stand about 4 amps, I think, which is all I need it to stand. So we're just going to do one long single phase. So the plan is we're going to mark this out, glue some plastic pegs to it. These are actually raw plugs. They're the cheapest thing I could find to cut up and super glue on. So when they're cut down, they're only going to be about 1/2 inch long. We'll do 10 of them around there, and then we'll wind sort of a serpentine around them. So yeah, right, I suppose I best get started, hadn't I? Right, I'll get started and I'll bring you back. Alright, see you in a minute. Right, yeah, that's all marked out. The marks won't be very clear, I don't think, on camera. It's all, I've cleaned it down with acetone and bits so the super glue actually sticks. So I put score lines in to mark it, because of course anything I'd have put on would have either affected the super glue or I'd have cleaned it off when I was prepping the surface. And we've got 10 little ends off off those raw plugs. Right, I'll get them glued on and we'll see what it looks like. There we go. They're all super glued on, 10 of them, spaced out equally, the same as the magnets are on this flywheel. So yeah, I think I'll start winding some coils round. Now you can do it, there's various different ways of doing it. I'm going to do like a serpentine thing, so we're just sort of going around them like that. You can do it a quick way. You can roll all your wire up into a ring if you like, and then feed it round. But I don't know how much wire I'm going to get on there, and I want as much as I can, so I'm going to do it the slow boring way. And I'm going to go inside, I'm going to sit with that thing and that, and spend the evening sat probably with the telly on or something, and just wind copper around and around and around until either it's full or I'm bored, one or the other, and we'll see what we end up with. Right, I'll bring you back when that's done. See you in a bit. Okay, well I don't like how that's going. It's winding on fine, these are doing the job, but there's not enough angle on the wire. Ideally we want the wire as upright as possible. It wants to be at right angles to the magnetic field if we can. Right, if we pretend that steel wool's your bit of copper wire, and this little off-cutter pipes is your magnet. If you pass the magnet at 90 degrees to the wire, you get the most generation. If you were to pass it along the wire, you'd get the least. You'd probably get nothing. So ideally we want it as close to right angles to it as we can get it. Now we're never going to get it at right angles doing it the way I am doing, but that is nowhere near. It's terrible, in fact. So what I have done is I've cut a load of little bits of plastic pipe. So I'm going to unwind this coil. I'm going to see about gluing them onto there, just something a bit bigger, and hopefully it will force the wire more in the direction of which I require. Yeah, we'll give it a go. Might just be wasting our time. It's worth a go though, isn't it? Let's give it a try, eh? Okay, it's all a bit cramped in here today. There is junk everywhere. The KTM's currently being used as a workbench, and it's horrid outside. But I thought we'd have another look at this, because, well, why not? Why not waste a bit more time and effort? So, anyone that saw the last video where we attempted to make a charging system, we made this set of windings, and they did a grand total of sod all. Yeah, just got it completely wrong. So, chuck them out of the way. So what we've done, we've got some thinner wire. and well, I had another go. I'm not even in shot there. There we go. Yeah, and I had another go. Now, it was 0.355 mil wire. I think that's about as thin as I could have got away with. And I started to make a serpentine coil. Unfortunately, the tension on the wire after I'd done my windings, excuse the hedgehogginess of this, it was, well, the tension of the wire was a little bit too high for what I was using for a backing. So that was a few hours down the Swanee and a whole lot of wire, yeah, so that didn't go well. Glued it back together a couple of times. You could probably see all the mucky marks on it. So what I've done, just so we can do an experiment, let's find it on here, I've made a smaller serpentine coil. Now I'm not expecting this to produce much, just something would be nice, see if we're heading in the right direction. And then I've also made that. Now this is steel plate. We've got flipping it. We've got 5 poles there because we've got 10 magnets. So we've got 5 poles there, so they're either all on north, all on south, and I've got the wire wrapped around it. Now, if your wire is running in the same direction as the magnets moving, you don't make any current. But the bolts, which are working like an iron core, should bend the current and it should do something. Now that is far too bulky to fit in the cover that I've got. I've just wrapped it in tape to hold the wire in place. And that one's a little bit too thin, and if I mount that in the cover, it will not be close enough to the magnets. So I think we'll get this thing up and running again. It's only roughly, but I have actually fastened the throttle cable to the twist grip this time, rather than holding a loose wire. And we'll connect them to the multimeter, and we'll just see if we get anything. Right, I'll get that thing up and running and I'll bring you back. We'll try the other one. Well, although noisy, that was sort of successful. Don't think I've damaged anything. You see, with the iron core you get quite a strong cogging effect, and it is drawn towards the magnets, so I don't think you heard it catch every now and then. But just before it was catching, that meter was getting up to about 8 volts. And, well, you saw what that one was doing. And that's not got anywhere near enough windings on it. So, we're going to class that as a success, I think, even though that went terribly wrong. So if I'd have made it a bit longer so the so the bends weren't quite as tight, I don't think that would have shattered. So we might have another go at doing that, and we'll see what happens, because this one has about 3 times as much wire on as that little serpentine coil. But I was quite happy with that. That gave us what, 6 volts was it? yeah, we're doing about 2,000 RPM at that, something around there. I said rather noisy, but it's surprising how easy this starts when you've got fuel in it. It was just about out last time. So, anyway, that, nice and successful. That, nice and successful, but won't fit in with the current design I've got here. I am sort of tempted to rip this all apart and make something completely new. Yes. See, there is a 190 flywheel back here, but we can't put a lighting coil in there because I've had to put a great big whopping spacer in and there just isn't enough room. I can just about squeeze the coil for the AC ignition in there, and it is blooming tight, but that does fit. But there is not enough room to put a lighting coil in as well, hence us going to all this effort. But yeah, that I am quite happy with. We've got 6 volts. What to do next? Do I make a thicker one of these, or do I do this, make another one the same size and have it over the top and have 2 phases? I think we'll stick with single phase for now, but yeah, that is definitely being classed as a success. If you want to learn more about how this stuff works, I use Robert Murray Smith. He does cracking videos. I think it's, I forget what his channel's called now. If you put his name in, you'll find it. He's on YouTube. But he's very good at such things, and he does a lot of experimentation. And it's where I got the ideas for this. It was, I think, a little generator he made called the Mighty Might, and he does a lot with serpentine coils. Okay, well, building on the success of earlier, I got a bit excited and carried away, and I've made another coil. This one's using the heavier gauge wire again, and lots of it. Now, it's not quite in proportion. Just to wind it, I just wound the coil around 2 points and then bent it into shape, and that thickness of wire, that amount of wire, it's taking some blooming doing, but I figured for testing I thought it should do. So yeah, let's fire this thing back up, make a lot of noise with it, and see what we get out of this one. I'll try and put the meter somewhere we can see it. Right, yeah, give us a moment. Oh dear, that's blooming noisy. Right, so that was, what, 6.5 volts when I got it in the right place. Now that thing's not wound perfect. It could be better, but we're not going to get enough voltage doing it that way. But you know, we have to try, because there just isn't enough room to get any more copper in than that with the setup we got. So there we go. We've tried. Turn the camera the other way. There we go. Incidentally, I had run out of the little plastic that I was using for the backing on that. So this is actually a clutch plate out of a bull taco with some holes drilled in it and a bit of tape wrapped around it. It's not done a bad job really. I might keep with that actually. Now we know that one's not going to do it. Yeah, we'll see about winding another coil, sort of out of the same gauge wire that that one's out of, and just see what we can get the voltage up to. Yes, right. I think that will do for now. Right, thank you for watching, we'll catch you later. Ta-da.